A warm welcome to 22 Clyde Road. For those of you who are with us physically in the building, I just want to point out that we're not expecting any fire alarms, but if we do have to leave in an emergency, there's a fire exit here and there's a fire exit at the top of the stairs. Out of courtesy to the people who are contributing this morning, if you could make sure that you have your mobile phones turned off. I think you don't necessarily normally get phone calls into this room, which can be a blessing, but in case you have some super duper way of being accessed, please, just out of courtesy, if you might turn them off. We're really pleased to participate and to support EirGrid in this initiative this morning. I suppose the electricity industry is a period of rapid change, and to prepare for and manage this change, EirGrid has done some work on looking at the factors that can influence the evolution of the electricity sector, and has pulled together a number of different scenarios, and we're going to hear about them this morning. And as I said, Engineers Ireland is very pleased to be able to support this piece of work. So there will be 3 presentations lasting about 35 minutes in total. Those presentations will be given by Murray Hayden, who will talk through the scenario development process. The next presentation will be by Ciaran Rabbitt, who will step through some of the content of the locations of the consultation report, and then Marie will come back and summarise the next steps in the scenario development and open up to the floor literally and virtually for questions and for discussion. So I'll hand you over to Marie now.
Thanks very much to Caroline, and also thanks very much to everybody here at Engineers Ireland for opening up your excellent facilities to us today to host this webinar, and many welcomes to those people who are in the room today in Clyde Road, and also those who are online with us via the Engineers Ireland website, or indeed the EirGrid website. I would just like to thank very much both Ciaran and Rachel from Engineers Ireland who've worked with us today to help us facilitate us here today, and to Amy back in the office in EirGrid, who's also managing the EirGrid web portal. So I just have a few slides here just to give a bit of context to tomorrow's energy scenarios, to a locations consultation report which was published 2 weeks ago by EirGrid. It is a consultation document, and we're looking for feedback from everybody who's interested in this subject, and the consultation remains open until the 11th of May. In my background, I'm just going to explain a bit about scenario planning and how it's linked in with grid development. I will recap on tomorrow's energy scenarios, which was a report we published last year, and talk a bit about the scenario development life cycle, because there are 3 key milestones in the scenario development lifestyle, and this is the second of those 3. I will probably abbreviate tomorrow's energy scenarios to TES frequently through this presentation, because it's a bit of a mouthful, so apologies if I do slip into that terminology. So just to start a bit about scenario planning and the grid. So many of you will know that at EirGrid, one of our roles is to plan the development of the grid to meet society's needs today and into the future. The size, type and location of generation and demand technologies that are connected to the power system very much determine how the grid is used. And obviously changes in these generation and demand technologies can change how the grid will be used in the future, and has in the past, and no doubt in the future, been the driver for grid development and grid reinforcement. You can see from the infographics there some of the technologies we consider in the TES report, both solar PV panels, electrification of the home, electric vehicles, data centres, onshore, offshore wind, fossil fuel, and many other technologies that both affect the generation and demand of electricity. And I think everybody understands that all of these are in a state of constant evolution and flux. And so when you're trying to anticipate how these may change so that you can plan the grid of today to meet tomorrow's needs, we've adopted what's called a scenario planning approach. So it's the method used by EirGrid for anticipating changes and for catering for the level of uncertainty surrounding how much each of these things will change into the future. From a grid development perspective, many of you will probably know that it can take 10 years or even longer to develop the grid large major reinforcement projects. So we're always trying to look forward to 10 or 20 years in the grid development cycle. As you go out further in time, the level of uncertainty increases greatly, and scenario planning is a very useful tool for coping with this level of uncertainty. The scenario planning process is an open consultation process, and through consultation we aim to get the best available information from the industry and society to help us develop the best set of assumptions upon which we will develop the grid. EirGrid published a document about, I think, 2 years ago on its website called Have Your Say, and it sets out the overall grid development process. It summarises it in a 6-step process. This is an extract from that report and just gives a quick overview of each of the steps in the process. Scenario planning is very much at the heart of step 1. How do we identify the future needs of the electricity grid? But scenarios are also used throughout the grid development process and life cycle, because at each step, as we move from one step to the next, we revalidate the ongoing need for projects against the current set of scenarios. In July of 2017, we published the TES 2017 report. This was following a period of consultation which had run earlier in the year. In TES, we set out our 4 scenarios that take us out to 2040. We gave them the catchy titles of Steady Evolution, Low Carbon Living, Slow Change, and Consumer Action. And each scenario has its own story in terms of economic developments, policy developments, changes in technology, and consumer and prosumer developments. If I was to try and summarise them very briefly, the way I describe them is that steady evolution is steady as she goes, a continuation of today's trends extrapolated into the future. Low carbon living sees a much greater level of change across all of our generation and demand technologies. And the way we describe that is as a policy or plan-led change. So we see large-scale developments incentivised by policy and government decisions. Slow change is maybe the pessimistic scenario, if you like. It fails to achieve climate aspirations and CO2 reduction targets. We don't see very much change in terms of the composition of the power system today. We do see demand increase, in fact, in all 4 scenarios, and that's mainly driven by increases in demand generated by, or sorry, caused by data centres. But apart from that, it's a fairly slow change to the system. Consumer action, kind of like low carbon living, sees quite a lot of change on the generation and demand side. But we see a lot more of this change being driven by consumers, and so we see a lot more of the change occurring on the distribution system rather than large-scale developments on the transmission system. So whilst low carbon living and consumer action and the portfolios behind them at a national level may look quite similar, they're actually very different in terms of their impact on grid usage. Each scenario has an associated portfolio, and the portfolios was the subject of last year's consultation. And I'll just show these up on the next slide. It's probably the best way to do this. So this is an extract from the TES 2017 report. And the figures in these are sort of locked down. We consider this a data freeze after we publish these. So all of these numbers form the basis of the locations consultation report and the next step in the TES 2017 cycle. The cycle will start again in 2019, so all of these will be refreshed in 2019. And I'll talk a bit about that at the end of my last presentation. So what you see on the table is, as I say, a subset of the information that was in the TES report. It provides data at a national level. So if you look, for example, at solar PV on that list, across the 4 scenarios in 2030, you could see the installation ranging from as low as 200 megawatts in slow change to as high as 2,500 megawatts in low carbon living. But it doesn't tell you anything about where this is connected. And the purpose of the locations consultation report is to try and gain input on where these technologies may be connected geographically on the system. I mentioned the scenario development life cycle for TES 2017. It's a 5-step process. So the scenarios consultation and publication took place last year. The locations consultation is currently open, and we would hope to conclude the consultation process, update the report based on the feedback received, and publish a final locations report in summer of 2018. After that, we enter into our analysis phase. At the conclusion of that would be the publication of what we call a needs assessment report, or system needs assessment report. And at the end of today, on my last set of presentation slides, I'll talk a little bit more about what that needs assessment report is. I think it's important people understand that, because it explains to you what the output really is of this TES consultation. As I say, the locations, the size, the quantity of generation and technology is what really affects how the grid is used, and the needs assessment report will show that. I'm going to hand over to Ciaran now to talk about some of the detail in the locations report. Ciaran and I are going to take questions and discussions on all three presentations at the end of the presentations. So thanks.
Thanks, Marie, and thanks, Caroline, for the introduction. So before I start, I'll give you an overview of the slides or the material that I'll run through. So the first thing I'll do is describe the approach to allocating scenario portfolio data to locations. So it's really important that I explain this well, because it's really the crux of the locations consultation. We're looking for feedback on the approach that we've taken, and we will use that feedback in the final report and in our final assumptions. I'll then provide an outline of the locations consultation report, so what you can expect to see in there. Describe the link between scenarios and locations. And I'll finish by giving some examples of the scenario portfolio data allocation and some examples of the methods we've used for different technologies. So this is a fairly simple table, a good one to start with. The basic concept here is to explain that for some technologies we have fixed locations across all scenarios, and for other technologies we have varying locations for different technologies. So I take offshore wind as an example of a technology with fixed locations. We have a set number of offshore wind locations in all scenarios, and depending on the scenario, the capacity at those locations scales up or down. Using data centers as an example of a technology where we have different locations, depending on the scenario, we can have more or less locations for slow change, which forecasts the lowest amount of data center capacity. We'll have the fewest number of data center locations, compared to low carbon living, which forecasts the highest amount of data center capacity. We'll have more locations. So I'll explain that a little bit more when I get into some of the examples. Okay, so a little bit of an outline of the report and what you can expect to see in there. So we've used regions as displayed on screen, and there's 8 different regions, and these regions are used by different government departments. We also use it for some of our publications, such as the Transmission Development Plan. So what you can expect to see is the TES portfolio capacities disaggregated using these regions as a means of presentation. We use these regions consistently throughout the report. In order to have a more detailed look at our different technologies and capacities, we focused on one particular year, and we've intentionally selected 2030, and the information that you see in the report will be reflective of that year. The reason we've chosen 2030, and there's a couple of different reasons. Firstly, in our portfolio, it's the first year that all 4 scenarios become active. So in 2020 we have 2 scenarios active, in 2025 we have 3, and in 2030 and 2040 we have 4 scenarios. So it's important that we look at all 4 scenarios in 2030. It's important from a energy policy perspective, and we have EU climate change targets or carbon emission targets, and Ireland's performance against those targets will be assessed in 2030, so it's important that we focus on that year. Also, closer to home, the white paper, the energy white paper, refers to 2030 as a milestone year, so an important year from a policy perspective. And lastly, from a system needs perspective, system needs being the last step in the development cycle for our scenarios, it's important that we consider any solutions that need to be in place by 2030. It can take, as Marie said, up to a decade to put those solutions in place. So from a network planning horizon perspective, 2030 is also an important year. In the report we cover a number of different technologies. So we have 8 on the screen here. Each technology is given its own section, and in there we describe the techniques that we've used to allocate the TES capacities or the portfolio capacities to our locations. So we look at solar PV, interconnectors, fossil fuel generation, electric vehicles, wind generation, which covers onshore and offshore wind, energy storage, heat pumps and data centers. So as I said, there's a section on each technology in our report which is available on our website. So how do our scenarios link to future locations? So it's an important concept. I suppose the purpose of scenarios is to prepare us for different eventualities or different futures. So as a means of achieving that, the locations that we use for different scenarios vary depending on the storyline. So Marie gave a good introduction on the storylines behind the scenario, so I'll now explain how they affect the different locations. So for steady evolution, we expect a continuation of current trends. We expect to see a mix between large and small scale renewables connecting to the distribution and transmission systems. We expect to see an increase in DC interconnection and an increase in storage locations. For slow change, we expect the pace of renewable energy development to slow down. This scenario aligns with the lowest level of demand growth. That's mainly due to a fewer number of data center locations connecting. As the fewest renewable generation locations of all our scenarios, and there are no new DC interconnection locations as part of this scenario. So as Marie said earlier, a fairly pessimistic scenario. Low carbon living is a plan-led scenario, and it aligns with there's an initiative in the National Planning Framework which talks about the use of state-owned lands for renewable energy development. So this scenario aligns with that initiative. It includes the highest level of demand growth of all the scenarios, mainly driven by data center capacity. Highest level of large-scale renewables connecting to the transmission system, and the highest number of DC interconnection locations. We have DC interconnection locations in 3 regions by 2030 under this scenario. So consumer action, it's all about the consumer being active in their energy efficiency and their energy consumption. We see a lot of community-led projects as part of this scenario. And the highest level of small-scale renewables connecting to the distribution system. And electric vehicles and heat pumps influence demand locations greatly in this scenario. Under this scenario, we expect the car fleet, 25% of the car fleet to be electric in 2030 under this scenario. And we see an increase in DC interconnection and storage locations. So moving on, I'll now move on to using some technologies to demonstrate the approach that we've taken in allocating capacities at the portfolio level. And we established back in the scenario consultation how we've taken those capacities and allocated them to different locations for different technologies. So I'll focus on 4 different technologies. Interconnectors. For wind generation, I'll look at offshore wind. For energy storage, we look at battery storage, and we'll look at data centers. So starting off with data centers, locations for data centers are primarily based on connection applications. So this is the most influential data set that we've used in determining our locations for data centers. This is a technology where the locations vary between scenarios, as I mentioned earlier. And we've taken a prioritization approach to capacity allocation using the connection application status. So what does that mean? For each connection application, they will be somewhere along the process in terms of connecting. And for connections which are kind of imminent or close to connecting to the network, they will be prioritized for allocation to a location. And for connections which are starting off on the process of connection, they will be kind of lower down in the priority for connection. So if I take 2 examples to try and explain that, for slow change, we will have fewer data center connections allocated to locations compared to low carbon living, which has the highest capacity and will have the most number of data center connections applied to locations. For some scenarios in 2030, we have capacities in excess of the forecast. So our GCS is forecasting 400 MVA in 2026. So low carbon living and consumer action, their forecasts in 2030 exceed that number. So we have used the scenario storylines to allocate capacities in excess of 1400 for those scenarios. So low carbon living, which aligns with a policy or plan-led approach to development, has the most diverse regional allocation of capacity. So we see data center developers seeking to connect outside of Dublin in this scenario. So consumer action experienced growth of small-scale data centres in 2030, and they're mainly positioned in urban centres and in our major cities, and that's aligned with the development of 5G communications networks. So how does that all look? If we take the allocation technique I've just described, how does it look in terms of a regional distribution of capacity? So as a reminder of the TES capacities, we can see them there in the table. So we have a range of 850 for slow change to 1950 for data centres. And this is how they are distributed regionally. So we can see that the vast majority of capacity is allocated to the Dublin region, and that's reflective of our connection applications. For low carbon living, we see more of a spread to different regions. And for consumer action, we also see more of a spread to different regions, and those capacities aligning with our urban centres in the west, the southwest and the midwest. Okay, if we move on to offshore wind. So we've taken a different approach to allocating capacities for offshore wind compared to data centres. So locations are based solely on connection applications for offshore wind technologies. For this technology, the locations are fixed. So we have the same number of locations across all of our scenarios, all 4 scenarios. The capacities at each location are allocated pro rata based on the spread of capacities in the connection applications. So we have a fixed number of locations, but the scale of capacity at each location increases or decreases depending on the scenario. For offshore wind, we expect the majority of capacity to connect to the east coast, as reflected in our applications received. So again, we'll have a look at the regional distribution of the capacities. As a reminder of the TES portfolio capacities, we can see low carbon living is a maximum of 3,000, and slow change is 250, so there's more than an order of magnitude in the difference, so it's a fairly broad range. And we can see that the regional distribution of capacities are the same across all the scenarios, because we're really just using the same number of locations and scaling up and scaling down depending on the overall portfolio. So we can see that regions on the east coast, in close proximity to the Irish Sea, dominate the profile. So we have Dublin, the southeast border and the mid-east prominent in our distribution, and that's because the majority of our connection applications have been for the east coast. So I'll move on to energy storage, and I'll take a closer look at batteries. So for batteries, we've categorised them in 2 ways. We have large-scale batteries, which are greater than or equal to 10 megawatts, and we have small-scale batteries, which are less than 10 megawatts. And we've taken 2 different approaches for allocating capacities for each. For the large-scale batteries, we've taken the same approach for allocation as we have for offshore. So again, the locations are based solely on connection applications. The locations are fixed across all scenarios. We have the same number of locations per scenario, and the capacities are scaled up and down pro rata based on the capacities in the connection applications. For small scale batteries, the locations are fixed again. We expect that the rollout of small scale batteries will be reflective of population densities. So to achieve our allocation, we've used distribution load as a proxy for population density. So our locations are fixed, but our capacities at each location scale up and down depending on the scenario. So the capacity at each location allocated pro rata based on distribution load. So we have a look at the outputs for that. We can see that large-scale batteries, similar to offshore wind, the regional distribution in each scenario is the same, but the magnitude of the scale of capacity in each region varies depending on the scenario. For small-scale batteries, it's a different picture, and because we're using distribution load as a proxy, we have all 8 regions in play, because we have distribution loaded all 8 regions. And we can see that regions with the highest density of population have the highest allocation of capacity. Okay, so this is my final slide, and we'll look at DC interconnection. So our DC interconnection locations are based on stakeholder feedback received during the scenario consultation. This is a technology where our locations vary depending on the scenario. We have a maximum of 3 regions with DC interconnection locations in 2030, and a minimum of 1 DC interconnection in the slow change scenario in 2030, and that's an existing interconnector, the east-west interconnector. So if we look at the data in tabular form, we can see in low carbon living we have 3 DC interconnectors. We have the east-west interconnector in the mid-east, we have Celtic in the southwest, and Greenlink in the southeast. In consumer action and steady evolution, we have 2 DC interconnectors, east-west and Celtic. And for slow change, we just have our 1 existing interconnector in the mid-east, which is the east-west interconnector. So that's all the material I have for you now. I might just finish up by reiterating our request for feedback. We're really looking for any suggestions you have on improving the allocation techniques that we've used, and it's really useful for us to improve on those methods before we embark on the system needs assessment stage. So I'll hand back to Marie, who's going to talk about next steps. Thank you.
Okay, thanks very much, Ciaran. So just to summarise, where are we going with all of this? As I said, this is very much about our grid development process, and the final publication in this series will be the system needs assessment. So once we conclude this consultation, we should have all of the information we need to model the power system under the 4 scenarios out into the future. The approach we take is that we apply the future energy scenarios to today's grid and just assess how does today's grid perform under each of those scenarios. It helps us identify whether there's any areas on today's grid which maybe are pushed to operate outside of standard in the future, and we'd call these areas of system need. And the system needs in turn are then analysed to understand exactly what is causing that problem and to validate it. I'll explain something about the validation in a second, and to see whether it needs further investigation. So the system needs assessment report, we haven't started it per se, but we've got an idea of what it might look like. So for example, you could expect to see maps of Ireland with today's grid, highlighting where today's grid is seeing areas of stress under each of these scenarios. And of course, we do expect to see system needs in all 4 scenarios because they all reflect quite a substantial change from today's grid. The scenario stories themselves and knowing what's the content and the difference between each of the scenario really helps us understand what's driving those system needs. So if we see something appear in just one scenario, we can really focus in on it and say, well, what is that big thing in that scenario that's different from the other scenarios that's causing this system need? And how likely is that to occur? And don't forget, obviously, these scenarios kind of go out to the edges of what we think is credible over the next 15 to 20 years. And in some cases, it would take quite a shift to bring us to that place, a shift in either policy or economic developments or society's attitudes. So we do need to, when I say validate the need, really understand how credible is the driver behind that need. Another good example of validation, it comes from something Ciaran mentioned, and it actually came through in one of our questions, and I'll come to it later. But a good example is the Greenlink project, the HVDC interconnector being developed by Element Power. When we started this process in 2017, in fact, it really started in 2016, but we locked down the data in 2017 when we concluded the last consultation. At that point in time, it wasn't very clear what additional interconnectors may proceed into the future. So we took a Celtic interconnector, which was in stages of development with RTE and EirGrid, and we also looked at a second interconnector to Great Britain. And at the time, we had applications in, a couple of applications for 500 megawatt interconnectors and a couple of applications in for a 1,000 megawatt interconnector. So we literally just went halfway between the two and picked a 750 megawatt interconnector. And that's gone into our locked down scenario as the third interconnector, excuse me. But since then, things have changed, and the Greenlink project has come through the project of common interest status, and it's a 500 megawatt interconnector. So there's a big difference between 750 and 500 on a grid our size. So when we model 750, we might see needs in that area, which on further investigation, we would validate against a 500 megawatt interconnector. So I know that sounds a little bit confusing, but it's just to explain that when you get these data freeze, data freeze is very important when you're doing system modeling, but at the same time, everything's always changing. So you really do need to validate those needs against the latest information you have at that point in time. So I hope that illustrates that situation. Any needs that are validated, we're not running out and doing projects at that point in time, we're bringing them into step 2 of the grid development process. And step 2 is where we start to look at what sort of technologies are out there that can address that need and bring the grid back into standard in that area. So the next steps in this TES 17 series is the location report consultation. This consultation closes on the 11th of May. And we were hoping then during summer to publish a final locations report. And the key thing that will be, depending on how much information we receive and how much feedback we receive, how quickly we can turn around and publish that final report. And then in winter 2018, the system needs assessment report will be published. And that effectively concludes the first cycle of scenario planning that EirGrid has adopted. So scenario planning is new for EirGrid. It's our first time doing this cycle. We've learned a lot through this process, and we'll bring all of those learnings into the next cycle. It was always our intention to update the scenarios every 2 years, so that brings us to what we call TES 19, already has the catchy title. And we will start the development of those scenarios in 2019. So we'll follow a similar process of stakeholder consultation and engagement to update the existing scenarios and maybe change the storylines as is appropriate for whatever we find ourselves confronting at that point in time. The one thing I will say is that we're going to shorten that whole cycle. This has taken the guts of 2 years to complete the TES 17 cycle, but in future, we fully expect to be able to do it within a single year. So as I say, we've learned a lot along the way. One of the things we've learned is that separating out the portfolio consultation from the locations, I don't think will be necessary going forward. It helps this time, helps socialise the idea of what the scenarios were, get people thinking about portfolios, get people thinking at a national level. And then we bring in, if you like, a more regional level through this process. But going forward, we're going to do that in a single go. And that will greatly shorten the development cycle. The other development we'll see in TES 19 is that we're going to introduce scenario planning to Northern Ireland as well. We're starting that process a bit earlier in summer of 2018. Obviously, we're starting a new process and engaging with a new suite of stakeholders in Northern Ireland. So we're just starting that a bit earlier. And don't ask me the question because I don't know the answer. Is this going to be a single publication or 2 separate publications? And will the scenarios be a single scenario for the island or 2 separate scenarios, like 4 different scenarios in Northern Ireland than you might get in Ireland? We haven't really worked through that, and that's something we're going to be working through as part of the stakeholder engagement, as part of developing the scenarios. So we'll be looking for feedback on that as well. So wrapping up the presentation side of this session now, I'd just like to say again, please review the report and provide your remarks to us by the 11th of May. It's available on EirGrid's website, and the questions and submissions can be sent to scenarios@eirgrid.com. So that's the end of the presentations, and I'm just going to move into a discussion piece as well. And I'm just going to start with the question that we did receive. We did canvass for questions to be submitted in advance of the webinar. So we got one set of questions about the Greenlink project, which I just mentioned. And those questions asked, why is it modelled as 750 megawatts when it's known to be 500? So I hope I've just explained the answer to that question. At the time, we weren't quite sure which of these interconnector applications was going to come through the process. So we went with 750 in TES 2017 report, and we've locked that down as a data freeze. But we do understand, obviously, we're now more likely looking at a 500 megawatt interconnector. The other question in relation to that project was, why is it not named? Why is it just Celtic is named and Greenlink isn't named? And hand on heart, that's just an oversight. We should have, of course, given it the name Greenlink, because by the time we were writing this locations report, Greenlink had the project of common interest status, and was also a direction from CRU to process its connection application. So apologies to Element Power and the developers. It absolutely should have been named in the report, and certainly will be in the final report on this matter. So I think they were the 2 key questions in relation to Greenlink. I think there was a third, I can't quite remember what it was, so if it comes to here, you might come back to me. I really hope that people in the room have questions or observations or would like to raise something for discussion, and they won't necessarily come through us. I might point to somebody else in the room to answer the questions. But Padraig Daly, you might just stand up there. Padraig has our microphone, And whilst we can hear you very well in the room without it, on the webinar they can't. So it's very important that if you wouldn't mind just taking the microphone before you start your question and just introducing yourself as well. So I will open to the floor, and Ciaran, you might come up with me because again we need the microphone so people can hear us on any responses. So hopefully somebody has a question. Okay, thank you.
Hi, Deborah Meegan from Quilcha. So just from a developer side perspective, looking at this locations report, again, there's concern we're looking at renewables and data centres and new technologies to be rolled out in Ireland over the next 5 and 10 years. What is the most important feedback you're looking for? I mean, we can obviously identify where we're looking at new wind farms or where potentially we would like to drive data centres and take that pull outside Dublin. But it's kind of cart before the horse in some respects when we look at this locations report. We're actually trying to do the work and the development now, yet we're not sure the grid will be there in place for when we need it, with the time frames involved. So for us to give the most, the best feedback to yourselves, what is it that you're going to be looking for ourselves? Is it very specific site locations, or is it in the general sense? And again, what's kind of the timeline, the turnaround, to give the developers confidence that if we decide to progress with some of these, whether it be wind or battery or so on, the confidence to go actually invest time and money in it based on location.
Okay. Okay, Deborah, so I suppose what type of feedback are we looking for? It's very much we're looking for, if you like, expert feedback. So you said, is it site-specific, region-specific? Yes, exactly that. So if you know about developments in an area that aren't obviously reflected in our scenarios, we really like to hear about that. Before we did this publication, we did engage with a number of stakeholders just to provide some input into the development of the consultation to make it quite meaningful. And we learn an awful lot through that process. There's an awful lot more knowledge out in the industry than there is in the walls of EirGrid. And so really that's what we're looking for is, what do you know, what sort of levels of certainty do you think exist around the area that you have a particular niche knowledge or level of interest? In relation to developer certainty, I think that it's maybe a slightly more complex question. I suppose what we're trying to do with this is identify the breadth of what's possible and develop a grid that can cater for multiple futures, not just one single future, not just the future that's based on people who've signed contracts and signed projects. So that, if you like, I don't want to use the word build and they shall come. That was an old phrase which maybe was less discretionary, but it's building a grid that can cater for a practical and reasonable set of futures across the generation and the demand, so that developers can come and there will be capacity on the grid for them to connect in, be it as generation or demand technologies. At the same time, we have a huge obligation to consumers and users, the bill payers, if you like, and society, the people who live with infrastructure, to make sure that we don't overdevelop the grid. It's an important and expensive piece of infrastructure, and we have to be very careful and selective about how we develop it. So we're trying to strike that balance between a grid which can cater flexibly for future needs, but isn't over-engineered and over-constructed and over-invested in to the detriment of society and of end users. And Scenarios is trying to help us do that. It's help us pick those projects which are the least worst regrets, is the phrase that's often used in scenario planning. So if we see a need in all 4 scenarios and we're confident, look, the future is certain here, as certain as it can be, let's progress and address that need. If we see something that's in 1 or 2 scenarios, it might be something we keep an eye on, or maybe something we develop in stages, so develop with smaller, smarter technologies, if you like, that overcome the need in the short term and keep a watching brief on how that need is developing in the long term. So I don't know if that really answers your question, Deborah, but that's certainly what we're trying, the ambition we have with scenario planning approach to grid development. Ciaran, you could stand up here beside me. Let them see your face.
Tom Bruton, consulting engineer. It's just very helpful to understand this process better at each consultation. So thank you for that presentation and work. I suppose when you're looking at the needs analysis, it's very much around grid infrastructure and grid expansion, and you're looking at long-term scenarios for low carbon living, consumer action, and I suppose like some of the work I've been involved in, the questions I've been thinking about is trying to look at that happening on a more aggressive timeline. That you would bring these data centres online in a more timely manner when they actually want to connect, or that we might have a vision where there are no more fossil fuel cars on the road in the 2030s, which is a firm policy direction. And so that there's a need to be maybe more aggressive and bring this into the shorter term forecasting. And, is there a role even in the short term for the generation capacity statement to sort of learn from this work, or to be more aggressive in bringing forward capacity as a solution to this and avoid network investment too? So it's just a question for you.
Okay, I'm going to give an answer to that, and then I'm going to see if anybody else in the room would like to also supplement my answer. So the latter part of what you were talking about there was the idea of generation as a generation capacity, I think, specifically, or some form of generation capacity as a way of supplementing or avoiding grid infrastructure, and the role of the capacity statement and scenario planning in that process. I suppose that's a tricky one, because we've moved away from the days of a sort of vertically integrated, centrally planned system, and rightfully so. So we have an open market to incentivize innovation and the development of the best technologies by the best developers in the best places, and that can mean therefore that you don't get this perfect optimization between grid development and generation location. The grid capacity, generation adequacy forecast, or capacity statement, sorry, I'm stuck in old names, serves a purpose about identifying is there enough capacity on the system to meet demand. It doesn't focus on the locational dimension of that, and is that capacity in the right place. The scenarios are intended to try and do that piece, and whilst we focus today on 2030, the scenarios do apply in 2020 and 2025 as well. And there are projects which are much shorter delivery time scales which are looked at in those timeframes to try and meet those needs, those more certain needs, if you like, that are in the near-term future. I think scenario planning provides the most benefit in the longer term, because it helps us really identify the trends. Where are we going? Where is the grid going to need to be developed? And those big, larger projects. I think the smaller developments are, as I say, they're more certain. The future is more certain in the next couple of years, and you can be more clear about what the need is. So I don't know whether anybody would like to respond to that question. Richard, maybe. So.
Well, I think just to add to that, Richard, if we take data centers as an example, and we think about the prioritisation approach we've taken to allocating capacities, you'll note that any connections of data centers which are imminent or happening in the short term will be covered by virtue of the fact that we take that approach to allocating capacities.
Richard Walsh, our generation, Grange Castle power plant. Also, just a couple of points I wanted to make. Have you considered, for example, the international investment, foreign direct investment into Ireland? That's just one point. As you know, companies come to Ireland every year. It affects our international image if we are perceived not to have sufficient power within the capital. I was at the data center conference in London last week, or 2 weeks ago, and also in the convention centre last autumn. And the general view from the multinationals is that there's a perception internationally that's being used by our other jurisdictions to lure private investment away from Dublin. So basically there's this perception that we don't have enough power in Dublin internationally on the market. So that's just, I think you should just maybe consider that. The capital has to have sufficient power. Many of the data centres I've spoken to said they wouldn't move outside Dublin. There would have to be a significant compelling reason to move, they said. So Dublin is prime target. It's one of the FLAC countries for development of data centres. The second thing I'd ask you to consider, have you looked at the Internet of Things, artificial intelligence, machine learning? This is a whole unknown area that's growing exponentially, and it's not really on the horizons, right? So that's the second thing I'd ask you to look at. And thirdly, a lot of the nodes are full at the moment throughout Ireland as regards solar and wind, and there's very little capacity to come up from the country. So if we're looking at this low carbon future, which I think is the government philosophy and policy for 2030s, I think the white paper is actually titled low carbon, and it has those two words mentioned in it. I would be suggesting new grid infrastructure to optimise the existing grid so we can bring more renewables onto the system. So they're just 3 comments I'd make.
Okay, thanks, Richard. They're all very good comments, and I could certainly provide answers to all 3. I might let Ciaran step in on them, but I'll start with the foreign direct investment. So we do work closely with the IDA, and we have consulted not just the IDA, but various government departments who are associated with direct foreign investment to get an understanding both of the future of things like data centres, but also are there other areas that we were aggressively out there pursuing in terms of direct foreign investment, so the development of the pharmaceutical industry and other industries as well. The point you raised about Dublin, the capital, being congested from a data centre, it's very valid. I think it's probably reasonably well known now that we've had an enormous level of interest and growth in Dublin in terms of the applications for data centres. And I think a statistic that I think helps contextualise that from a grid development perspective is that, say, pre-2013 or 14, before these started aggressively coming in seeking to connect, we were planning a grid development around approximately a 1% per annum growth in load in Dublin. But these data centres, which are currently in the process, equate to more than 50% growth over a period of 6 or 7 years. So there's a very sizable change in terms of the demand on the Dublin network, which quite frankly wasn't foreseen. And I'm no doubt that closer collaboration in the past with the IDA and the government could have helped us perhaps see that better coming down the track. So things like this more open engagement around the assumptions is aiming, back to Deborah's point, to get exactly that. What do you know that's going on that we don't or possibly haven't paid attention to? And the issue of capacity in Dublin is one of a lot of concern to us as well as to the data centre development. And the last thing we want is the grid to be an obstacle to inward investment in Ireland. So we're doing everything we can to try and make sure that the capacity is there. And I agree with your sentiments in relation to the data centre owners and their desire to locate outside of Dublin. We've had a lot of discussions with them ourselves to encourage or discuss what are those things that would lure them to parts of the capacity where there is the grid where there's capacity. Best I can say is those discussions are ongoing, and we're still hoping that ourselves and the various government bodies can help incentivise greater diversification in data centre location. It makes a lot of sense from a grid perspective, but also from society, regionalisation of jobs, etc. So, and there's plenty of places on the grid where, almost to your third point, if you like, there's places on the grid where there's a lot of generation and not much demand, and particularly along the western coast and southwest, where we have a lot of renewable generation technology. Wind in particular has been developed in these areas, but not as much demand. The majority of the demand is in the south and the east coast. And so we're looking for infrastructure to transfer that generation from the west to the east. Wouldn't it be great if we could get some of the demand to go from the east to the west? And that would be exactly that. So if, as John O'Sullivan would say, if I was a benign dictator and I could control everything, I would do a bit of that. But, that's not the marketplace in which we work. So all we can do is try and develop the grid and send out those signals very clearly to try and incentivize people to go to places where there is capacity, assuming that makes sense for other reasons. It's not all about the grid, so we have to remember that. Do you want to talk about the Internet of Things?
Yeah.
You're young, you know these things.
I have a smartphone. I'm glad you brought it up. Consumer action is a scenario that aligns itself with the kind of expansion in use of smart devices and Internet of Things, and we've assumed that we'll have an expansion of edge data centres as part of that scenario, and we've aligned that assumption with the rollout of 5G communications networks. But to go back to a point that Marie made earlier, we as this is a consultation, and we rely on industry leaders such as yourselves to provide us information on how we can improve those assumptions. I think we've only made that assumption for one scenario, for consumer action, and the pace of that 5G rollout will determine how quickly we see those capacities grow. If there's information available or industry papers that we could use to validate those assumptions or to improve on them, we welcome them.
There is a paper published
Okay.
by an industry paper. I don't know if you've seen it. It identifies all the data centers in Dublin.
Right.
That's their locations and their neighbours and their industry.
Is it Host in Ireland or is it?
I can send it to you.
Yeah, great. Yeah.
It's an industry publication, but it gives
Yep.
a fair bit of detail.
Okay. Thanks, Richard.
Frank Burke, Lumclune Energy. I'm interested in the backgrounds and the sort of drivers you have for energy storage in the different scenarios, and what different uses for energy storage. Like, you know, you just have a thing, energy storage, but there's all sorts of different kinds of energy storage for different things, like for grid stability, for DS3, for ramping in a scenario where you've got a lot of PV, for, you know, smoothing out the variations in renewable energy and so on. So I was wondering to what extent you have taken different kinds of energy storage into account for different purposes.
Yeah, that's a really good question, Frank, because it really does affect the grid usage. If something's being used for arbitrage, energy arbitrage as opposed to short-term frequency recovery. And I think this is, back to you, exactly the kind of information I'd be really interested in seeing is where you think the developments are going to go in terms of quantities. If you were to take our portfolio, like what percentage might be sort of a system service type installation, what percentage might be energy arbitrage. That's a great, I think it's quite a great unknown. So we included quite a lot of battery technology and storage technology in the TES last year. Following this whole consultation engagement process, there was a lot to suggest that as we head out into the longer distant future in particular, you know, batteries complementing variable generation and storage, etc., that it all, you know, it's a cohesive picture, but it's not as obvious to me how that will break down between the two. So at this stage, we're sort of portfolio level, we're national level, we're location level. We have assumed a certain amount in our running. Actually, the man up there might be the person to talk to, Porter Daly, who's our expert on plexus modelling and dispatches and how we model these different technologies in the full 8760-hour analysis of the grid. I'd be able to give you a bit more information perhaps on that, but we'd be very interested in your input into those things as well.
Fergus Sharkey from SAAI. I have two questions which are somewhat interlinked, and you've touched a little bit on it already. But in the different scenarios, in the different scenarios, you run into different levels of new infrastructure requirements, and that, I guess, impacts their ability for delivery. So is there any position that EirGrid are taking in terms of trying to utilise existing infrastructure better and trying to drive towards a particular scenario? And that comes into the second question, which is somewhat similar, which is, you know, what's EirGrid's role, or what do you see as EirGrid's role to that drive for decarbonisation towards the more extreme scenarios? Are you just reacting to demand, or are you trying to push for a particular scenario internally or within your strategy?
Do you want to?
Yeah, I might address the first question. So the work in determining how we resolve system needs, it will be covered in the system needs phase of the scenario development. But I think it's important to note that all four scenarios are considered equal, and we assess the needs equally against each of the four scenarios. If there's a solution that exists kind of consistently across, there's a need that exists consistently across those four solutions, we look at what infrastructure would be required. But it's definitely a case of identify the need first, and then follow up with an infrastructure solution if economically justified.
And I'd just like to add to that, in the Have You Say document and the Grid Development Strategy document in particular, there's a very stated there's three strategic objectives of that, and one of them is to minimise the construction of new assets, or I think actually probably phrased to maximise the use of existing assets. So when we go to that step 2 of the grid development process and we look at solutions, the driver is to maximise the use of existing assets with whatever technologies are available to us to do that. So that's certainly in terms of solutions. Now, your second part of your question is tied in with that, and it's to what extent is EirGrid out there saying this is the right scenario that we should pursue as a society? We're not. Okay, so I think it's really important that we're not seen or we're not interpreted to be saying society would be better off if we went down a low carbon route or a slow change route or steady evolution or any of those, because there's so much more to these scenarios than just the grid. There's a huge question in relation to climate policy. There's economic impacts of these different scenarios as well. But what the scenarios can do and I think have done quite effectively over the last year, is they provided a platform of information, gathered information from a lot of experts around the industry and beyond, and centralise that in a single report, which people can use then as a straw man, if you like, for discussion and debate, for policy development, for interacting with policy consultations, for interacting with stakeholders, investors in fact even as well. It's good to see them being used for that purpose, and it's good to have that sort of platform or that central document. And I think our role, EirGrid as a state body, I think our role is very firmly in the provision of information where we have it, and provision of expertise where we have it. And our expertise, I think, in this regard would be very much about stability of the grid, the issues that have been talked about in relation to integrating renewable electricity onto the grid, the capacity of the grid today to cope with tomorrow. And yes, maybe in that system needs assessment, you might see one scenario might drive a lot of system needs, but maybe it's associated with a much wider benefit than just the needs on the grid. And another scenario, slow change may see very few grid or system needs, but that doesn't necessarily mean slow change is the right avenue for government policy, shall we say, to pursue. So I think we would say that our role is to provide information and expertise where we have it, to be supplemented by the expertise that lies within the rest of industry and government.
Enda Gallagher, Department of Climate Action. Marie, just a couple of quick comments on interconnection, if I may. First, to add to your comments about Greenlink, I noticed that the regulator CRU published an information paper on interconnection in the last week or two, and they confirmed that they have received an application from Greenlink, and they're going to reach a preliminary decision this September. I suppose there are two sort of processes going on in terms of national sort of interconnection policy at the moment. CRU are obviously looking at the regulatory side of things, and then the department is looking at the policy side. And in terms of the national policy piece, the department published an information paper and a draft policy statement on interconnection in January for public consultation, and we're working through to finalising the policy statement on that. And meanwhile, CRU are looking at the regulatory side. As I say, they published a paper in the last couple of weeks, and they're looking to publish another paper in the next month or two as well. So maybe just for people to be aware of those developments in that area.
Yes, thanks, Enda. I saw that actually. We're actually hit 12 o'clock already, and I'm happy to take maybe 2 or 3 more questions, but then we'll probably have to wrap it up. So is there anybody who would like to ask a question who hasn't asked one yet, or anybody like to? Okay, anybody else like to have another go? Sorry.
Peter Lynch here from Quilcha. Just a question on kind of assumptions that are feeding into both the locational piece as well as the refresh of the TES report next year, and that's specifically to do with European target setting for 2030. Obviously we're aware that 27% was a baseline that's likely to move up from there, and there seems to be kind of a broadening acknowledgement of that to be the case. So just wanted to check in on where and how that feeds into your analysis.
I think it'd be a very important part of the analysis. Like when we were developing these scenarios back in, as I say, it was really 2016 when we started pulling these portfolios together, there was huge uncertainty over what was coming out of the Paris Agreement and the EU climate action targets or goal setting, if you like. It was a very uncertain landscape, but I think I wouldn't say it was particularly bedded down just yet. So all we can do is work with the best information we have available at the time. I think it's maybe worth noting in this scenario development cycle, and again, when we start the consultation next time, we'll be really looking for input on this again. We didn't develop the scenarios to achieve targets. We developed the scenarios in line with the feedback we got from members of the industry and experts about where they saw their technology going. And then we reflected what those portfolios look like in terms of carbon emissions and how that might link with some carbon reduction link. So we weren't focusing on having 40% of electricity from renewable or specific targets, but we put in, I think it was a 6.8 megatons of carbon as some sort of reference point. We said if it's below 6.8, it's probably achieving more than the ambitions, and if it's above 6.8, it probably isn't quite achieving them. But at that point, there weren't any specific goals. The refresh it won't just be a refresh, it's going to be a complete new consultation from scratch. Here we go. The only thing that's, if you like, the fact that everybody will have done it once will be the big thing. So you'll know what we're talking about the next time we knock on your door and go, hi, we're back with our scenarios. What do you think is the latest information? And I can't tell you the wealth of information, even recently, that's been coming our way, that we can't wait to dive into, to analyse further development of TES 19 scenarios. This industry changes at a phenomenal pace in every single direction, and every time you're brave enough to publish something, you can be pretty sure it's out of date the next day. So it'll be that same consultation process. It'll be more than a refresh; it's a full start again, if you like.
I might just add, at a recent NSOE workshop on scenarios, there was an idea tabled to have a scenario which meets the climate change ambitions, and then kind of work backwards towards what would be required to achieve that. So, just to reiterate what Marie said, there's definitely an option to explore that further.
I think we've maybe just one last question, and we'll wrap up then. If you'd like to bring the microphone over, Paul, just so that.
Richard Walsh, Grange Power. With the amount of renewable technology that's coming onto the system and that's planned to come onto the system, and considering that we have the system at the moment is mainly driven by base load combined cycle power stations, what provisions are being made or considered in the future for flexible plant? Because as the wind lowers within, let's say, a half an hour period, you're going to have to bring up the combined cycles, and we know combined cycles were never designed for anything other than base load 365 24/7. So the blades actually would be significantly stressed, and it would be only a matter of time before a catastrophic failure would occur in a combined cycle if you operate a base load combined cycle as a part load plant. So I make the point that any future scenario considering extensive renewables or low carbon with high penetrations of wind or solar would also equally require significant amounts of a flexible plant to mitigate any catastrophic losses.
Yeah, you're right, Richard. There's a huge requirement there. We're going to have the levels, particularly if you look at something like low carbon living with very high levels of offshore and onshore renewable energy. They're also coupled with high levels of battery storage and HVDC interconnection, and very high levels of much higher levels of demand as well. So there's a certain element of complementary nature there. And when we ran these portfolios through our modelling tools, our dispatch modelling tools, I think did we have 75% SNSP as a limit, I think, in one, just to see, were they still viable? And we were kind of assuming that the system can operate at 75% instantaneous penetration. And that does drive the need for flexible technologies, no question about it, and they are part of the portfolios that are in the TES document.
Just as an aside, the system service budget forecasted for 2020 is €230 million, which, as well as investment signal to new technologies, is supposed to provide signal to existing plants to, if it's cost benefit to them, given the revenue through system services, to retrofit their technologies to make them more flexible.
Okay. Can I just say, I'll give Deborah, only because she's a girl, we need more women speaking at these events.
Thanks, Marie. You might regret something was the last question. It's always going to be doozy. We talk about scenario planning, and you already talked about TES 2019. Again, I think from an industry perspective, what we'd like to see, obviously, is some outcome from this, from certainty. So what are the next steps? What is the timeline to say, based on TES 17, when are we going to see a plan that says, with all the information we've gathered, these are the investments we're going to start work on, because there's certainty, recognising that when 2019 comes up, there will be further investments in infrastructure, be that upgrading of existing grid or development of new grid. But the key is to see an actual outcome from what has been a very comprehensive process. But when do you see those outcomes coming to the fore? So again, there's a level of certainty for industry to plan and to invest.
So what TES changes is, if you like, the fundamental assumptions that go into our grid development process, but not the grid development process overall itself, as in we will still put through system needs as we identify them. Now we're identifying them through scenarios. Previously we identified them through, and now we're a set of assumptions. But once a system need is identified, it goes through a grid development process, and if a project is required, it will start to appear in published in statutory documents like the 10-year network development plan. So, grid development is an ongoing evolutionary process. It's not a start-stop process. There's constantly people addressing and investigating system needs as they appear, be that through a connections process or through a scenarios process, and seeking to develop options around and solutions around those and bring them through the grid development cycle. So the 10-year network development plan probably remains the central document where you see what projects are coming forward, and then specific projects obviously have their own communications portal around them as well. So so don't expect to see a seismic change, if you like, after the system needs assessment. That tells you what needs are we looking into going forward, and then you're back into the traditional grid development process for the moment anyway. It's nothing to say that won't change. I really do have to draw a line underneath it because we're 10 minutes over time. I'm delighted at that, because when we were wrapping up our slides at 11:30, I thought we could be out of here at 20 to 12. So thank you so much, everybody in the room, for your questions and your involvement in today's presentation. And again, we're really seeking responses through our consultation from everybody here and everybody online. So I will draw the line there and say thank you very much. Do I shut this down, do you think, or do I leave it here? I'll step